Alright, welcome back. Here's our second video for today, and we're going to do section 3.9, and the title of this is Inverse Property of Addition with Fraction Equations. So we're going to call this Inverse Property of Addition in fraction equations. I just want to check and make sure that it's recording. Alright, so this section is going to be a review again. It's similar to sections that we've done in the past. And we're going to be solving questions that look like this is kind of going to be our goal. When something like this, x plus 1 and 1/2 equals 3 and 3/4. And we've done this before with decimals, and we've done it with regular, just whole numbers. But we're going to be doing it with fractions this time, and I want to show you the steps for how this works. Okay, if you recall, the inverse property of addition goes like this, and it says that if I take any number and I add it to that number's opposite, I will always get 0. And this is the key that we use to solve all of these algebra equations. So notice again, we are returning to equations because we have an equal sign. Equations have equal signs, expressions don't, right? Equations have equals, and we solve them. Expressions have no equal sign, and we simplify them. These are useful, but not nearly as useful as equations are in describing the world around us. Okay, let's look at quickly how we would solve one of these, and if it was a little bit easier. Recall that if I had something like this, x plus 4 equals 10. Now I can ask myself, well, something plus 4 is 10, and I could probably tell that it's going to be 6. But I want to go through our steps of using the inverse property of addition to really remember how this goes and how it's going to look. So I want to get the x by itself. That means I'm going to get rid of that 4 that's over there. The best way to get rid of a 4 is to subtract exactly 4 from this side of the equation. Now if I take it from this side, recall that the fraction is kind of like a little balance scale, and I have to do the same thing to the other side. Now I can simplify this side. X plus 4 minus 4, I can simplify easily down to just an x. On the other side, 10 minus 4 turns into a 6. And that's how I used my inverse property of addition to solve this equation. We are going to be basically doing exactly this, only using fractions. And when we have the fractions in there, we'll have the additional step of needing to simplify, make common denominators, and do all the other things that we've been doing with fractions up until now. So let's again take this question and look at how we would solve it. We'll use it as our example 1. We have x plus 1/2 equals 3 and 3/4. Well, I can easily see, oops, this is supposed to be 1.5. I can easily see that I'm going to need to get rid of this side of the equation. Or not this side, the 1.5 that's over here. So I'm going to do exactly what I did before, and I'm just going to get rid of that side. So I'm going to say x plus 1/2 minus 1.5. So now I can turn this into a 0 and get rid of it. But if I do that to this side, I have to do it to the other side. So now I can simplify here because I added my minus 1.5 to this side. So now I have x, because 1.5 minus 1.5 is 0, and I don't have to write my plus 0. So I have x equals 3/4 minus 1/2. Now, when I'm subtracting fractions, recall that I need to find a common denominator. What I could do is multiply each other, this side by 4 and this side by 2, but I can see an easy denominator that's going to work. So I'm just going to multiply both of these by 2, and rewrite what I've got. I have 3/4 minus 1 and 2/4. I can do this easily now that the denominators are the same. I can write x equals 3 minus 1 is 2, and 3/4 minus 2/4 is 1/4. Now I have my answer. Beautiful, easy to do. Okay, if you feel like you get it, go ahead and stop. I'm going to do 2 more examples. Example 2. Alright, example 2 looks like this. We're going to do x plus 2/3 equals 5/6. Alright, just like before, I need to get my x by itself on this side. So I'm going to use my inverse property of addition, and I'm going to do x plus 2/3 minus 2/3. That will give me 0 on this side, and it'll leave this little x all by itself. Exactly what I want it to be. But I need to do the same thing with my other side. So I'm going to do 5/6 minus 2/3. Okay, so now I'm subtracting fractions again. I need to find common denominators. I can easily see that I can just turn this 3 into a 6 by multiplying by 2, and I have to do the same to both sides. So I have 5/6 minus 4/6. 5 minus 4 is 1, and it gives me 1/6. Because always remember, we don't change our denominators when we're subtracting or adding fractions. Okay, let's take a look at another one. This one looks like this. 1/7 plus x equals 5/7. Excuse me. Alright, so this time, it's a little weird. I have my x on the wrong side. Wait, but I can just use the commutative property and move that around. So I can just rewrite this as x plus 1/7 equals 5/7. And it doesn't really matter, remember, because I can just do it however I like. So I need to get rid of this 1/7 over here. So I'm going to have x plus 1/7 minus 1/7 equals 5/7. And I need to do the same thing I did to both sides, minus 1/7. This side easily turns into an x all by itself. And 5/7, this is nice. I don't even have to change my denominators. 5 minus 1 is 4, so I have 4/7. I'm simplified. I'm good to go. Oops, I forgot to put a box. I keep forgetting to do that. Alright, we'll do one more because they're a little bit quicker than I originally anticipated. Let's take a look at this one. We have y plus 1/2 equals 5/6. Alright, we have 1/2 on this side, so let's get rid of it. Plus 1/2 minus 1/2 equals 5/6 minus 1/2. And I have y by itself. I need to turn this into a 6, so I'm going to multiply the top and the bottom by 3. So I have 5/6 minus, I'm right, sorry, 3/6. 5/6 minus 3/6, y equals, 5 minus 3 is 2/6. Now I'm not done. I need to simplify. I can easily see that both of these are even, so I can turn them into, I can divide them both by 2. So I have y equals 1/3 for my answer. Pretty much it. Good luck. I think you should be able to get it from here.